Hello everyone. In this session, I'm going to go over problem number 2.18 revised. And the purpose of this video is basically getting you familiarized with English units. Let's go to the problem statement first, and then I'll explain to you what the English units they're talking about. The resistance wire of a 1,000-watt iron, 1 foot long, and has a diameter of 0.5 in inches. Determine the rate of heat generation in the wire per unit volume, BTU hour per feet cube. This is the reason why I'm showing you this, so how to convert it. And also the heat flux on the outer surface of the wire, BTU hour feet square, as a result of this heat generation. So the dimensions are there, and the heat, the rating of the wire is given. So I have transferred the pertinent information on my workout sheet here, and so 1,000 watts, basically it means a 1,000-watt rating means the resistance of wire will convert electrical energy into heat. Therefore, the rate of heat generation is EG is simply nothing but a power rating of the heater. That is the important thing to remember when we're doing this problem is when the rating is given, that means he has given you this, okay? And the question statements are there. Two questions which I showed you earlier are there, and let's get started. So first thing is heat generated per unit volume. That was question number one. The symbol for that is small e equaled capital E by volume of the wire. Volume of the wire is pi d square L, right? Pi d square area times the length. So going straight to the units, the values he has given, 1,000 watts of total energy generated divided by pi, area is diameter 0.5, that is in inches. So we need to convert it into feet, divided by 12, that becomes feet, pi d square, that is divided by 4, times the length of it. The length is, it is luckily in this case, this is already in one feet. So that's what we have. So the whole thing has to be multiplied because we had to convert watts into BTU. With 1 watt to BTU is 3 what is watt per BTU? It is 3.412 BTU per hour is equivalent to 1 watt. Yeah. So this is the critical thing is 3.412 BTU per watt. So simplifying that, you will come up with an answer of 2.50 times 10 to the power of 6 BTU hour feet cube. And that is the first part he wanted is in terms of heat generator per feet cube. That's the first answer. The flux, again, pretty straightforward, is capital E dot and area of the surface of the wire. Okay, here is the volume of the wire. Here is the area of the surface of the wire. Area of the surface of the wire is pi dl. So let's plug those values. 1,000 watts. Pi, convert into feet again, and the length is already in feet, pi dl, and this watts has to be converted into BTU, 3.412 BTU hour per watt. And the value for that one is 2.61 10 to the power of 4 BTU hour feet square. Here hour feet cube or feet square, and so this is how you have to make sure the conversion factor is right there, and so you address you bring into the English units. So that is simple as that. Okay. All right, we got both answers, question number 1 and question number 2, heat flux and the heat generator.